All right, we'll be considering this question. We want to treat this topic EMF. I know a lot of students have some difficulties with this topic, so that is why I want to treat it using this question. Now, let me just give you this analogy. The difference between EMF and P, potential difference, or what you call normal voltage, the difference between them is more like, say, this is the food you eat and this is the energy you get from the food. What do I mean? You take certain amount of food, it produces energy, plus some are lost, some are given out as your physics. Now, that is why we have this. So, now, if you see, the essence of eating food is to get energy. So, they are almost the same, except that some food are undigested and are passed out. So, therefore, we have EMF to be equals to useful voltage plus lost voltage. Useful voltage plus lost voltage. Now, for instance, if you buy a battery, for instance, you get a cell, and when you get a Tiger battery, you see there they may write 1.5 volts. That is the EMF. That is the input. But by the time you connect it to a voltmeter to read, or by the time you connect it to any appliances, what is going to give to you will be probably 1.2 volts or 1.3 volts. Now, there's a missing voltage there, a lost voltage of 0.3. So that is what we call the lost voltage. So that is why EMF has the same unit as volts, while your useful voltage also has the same unit as volts. So I'm just trying to tell you the difference between them. So when you see them in exam, you have proper understanding. So from here, we are going to be having our EMF to be equals to IV. Our voltage is IV. Then the lost voltage is also voltage, which is I small r. The lost voltage now is due to internal resistance. So from here we have this, our V is R. So we have R plus small r. So this is the formula for our EMF. So this is the formula to use easily. Alright, so with this understanding, you will be able to solve any question if you attempt it. So at least you have proper understanding. When you have one given to you high voltage, the other one given to you having voltage or smaller voltage, it's just telling you that there's a loss in voltage. So let's go to the question we have for today, having the foundational knowledge of what EMF is. Now see, a cell of EMF 1.5 volts. So we have EMF, so solution, EMF is 1.5 volts. Is connected in series with a resistor of resistance 3 ohms. So you have your capital R, 3 ohms. Now, the problem some students make is resistance, they use small r here. How do I know big R from small r? That is external resistance and internal resistance. Whenever you hear connected, then it's big R, because the small r is internal resistance. You don't need to connect, it's internal resistance that is in the cell. So that settles it. Now, it's connected in series with a resistance of 3 ohms. Then they said a voltmeter connected across the cell registered 0.9 volts. That is what we are saying. You see now, the manufacturer of the battery manufacture 1.5, but when you use voltmeter to read it, you are getting 0.9. That means there's a lost voltage. So which means you have your V to be equals to 0.9 volts. Now the question is, calculate the internal resistance of the cell. Calculate the internal resistance of the cell. There are so many methods to adopt here, but the easiest one is to have EMF equals to I r plus small r. You are looking for small r. All right. Now, do we have our I? We don't know I, so you can solve for your I. Solve for I. Remember, v equals to ir. We know our v, we know our r, so I will be equals to v over r, which is equals to, our v is 0.9 over 3. That should give us 0.3. That should be 0.3. All right. So if we have this, then you can then slot in your I here to look for your R. So our EMF is 1.5. Our EMF is 1.5 is equal to, our I is 0.3. Our R, from here, our R is 3. Plus, we are looking for small r. All right. So from here, we have 1.5 equals to, this time this will give us 0.9 plus 0.3 small r. All right. So we have 0.3 small r equals to 1.5 minus 0.9. This should give us 0.6. Yeah, it should give us 0.6. So 0.3 r equals to this. So r will be equals to 0.6 over 0.3, and this should this cancel this here 2. So you have 2 ohms. 2 ohms. So that settles this. So you have 2 ohms when you solve this. Now I told you there are different methods you can use. Of course, you can also adopt another method which is a bit simple. You can just look for the lost voltage, which is carrying the small r. So our lost voltage, which is small voltage, is I small r, right? Now, we know the lost voltage from here. The lost voltage is this voltage minus this. That is, the voltage minus the EMF will give you the lost voltage from our previous formula, which is EMF is equal to useful voltage plus lost voltage. So this is useful voltage minus EMF. You get your lost voltage. That is going to be 0.6. So 0.6 equals to I small r. We don't know I, but we have solved for I before, which is 0.3. So 0.6 equals to 0.3 r. So r is equal to 0.6 over 0.3, and that still gives us 2 ohms. 2 ohms. So that settles it. So you can check more wire question and Jamb question. The basis, the reason why I solve this is because of the experience I have with students, having difficulty understanding the difference between EMF and voltage. Or sometimes they call the useful voltage the terminal voltage, because it is the voltage you will read when you put a wire between the two terminals. So that's why sometimes we call it terminal voltage, because when you put a voltmeter, the wire of a voltmeter to the positive terminal and the negative terminal. So when you read, the voltage you are going to get is the useful voltage, and it's also called terminal voltage. So sometimes they call it terminal voltage. So you can solve as many questions as possible and ask your question below. Just comment and like. Thank you.